Be starting in just about a minute. Just to give a quick update, the first talk that I'm going to be talking about is giving you an overview of what Project Velocity is, give some demos, how do you use it, what the APIs are, and then subsequently there's another talk following this in the same room given by Anil, who will going to go into the details of the kind of the internals of how we did this Velocity project. So this is kind of the intro, and that's more of the advanced talk. All right. So what is Project Velocity? It is a distributed cache. So there will be a lot of questions. People are like, oh, we heard Velocity. What is it? It is a distributed cache. So this session, what you're going to be learning about is what is distributed caching, and what are some of the types of data that you can cache, and what are the properties of that type of data. What is Velocity? Obviously, when can I get it? How do I use it, and how is it going to help my application? Can it help my application to perform, to scale, and make it highly available? So we'll have a bunch of demos all around that. And finally, we'll also go dig into some of the features of Velocity as well. So why are we standing here today talking about distributed caching? What has made this possible? We see that there's a number of trends that have made this possible. The first one is that the application architecture is evolving. The requirements are evolving. Data no longer just comes from rows and tables and not just from SQL sources, but it's coming from all over the place. It's coming from the web. It's coming as XML documents, as files, from web services, and so on. So the shape and form of the data is changing, right? It's no longer just rows and tables or columns, but you have it in all sorts of shapes. So that's where the applications requirements are evolving. And also, you want the applications to be always available. Even your intranet applications, you don't want them to be down, right? You want them to be always up and running. You want them to scale. So that's the evolving application requirements. Now, following that, there's also the evolving application architectures to support some of these things. We already recognize the multi-tier model. There's clearly a data tier, an app tier, a web tier. Right? And also, you have now data coming from all over the place, and you want to actually have the data now close to the mid-tier logic where you're performing some of the operations. Also, there's a clear recognition that there are different types of data, and they have different characteristics. So they're kind of, how do you cache such data, or how do you have your data in that application logic? Third key piece of this thing is the evolving business requirements. I mean, looking at the economy today, you realize that your business requirement clearly is to be able to reuse machines as much as possible, not spend an extra dime where you don't have to, and save money, right? And what is making all this possible is the underlying hardware trends. You see memory prices dropping rapidly. You can now have gigabytes or even terabytes of memory chips on your machines. It's also very cheap to actually take a bunch of standard machines and kind of put them together on your gigabit LAN or your 100 Mbps LAN, and you get like multiple machines together. These four things together is the reason why we're able to stand here and talk about distributed caching and how it can help your application. Now I'm going to go through a few slides explaining what are the types of data that people cache in the distributed caches and what their properties are. And you'll realize once kind of done with the Velocity talk, you'll realize how Velocity's features can actually help you with these different types of data. The first kind of data is what we call as reference data. Reference data, by the name, it says it's a piece of reference, right? So things like your catalog, your employee catalog, or user data. If you go to Amazon, all the Amazon shopping catalog. These are all kind of examples of reference data. And reference data is the key property is it's read-only primarily. It's written very infrequently, maybe once a day or maybe once in a few weeks. But the scale requirement is that you should be able to handle a large number of read requests on this smaller piece of data. And let's take a classic scenario, social networking scenario. If you take example like Facebook or MySpace, they have terabytes of data of your user IDs, your friend lists, usernames that they have to cache and get it very fast. So they run like distributed caching servers over hundreds of machines that cache this. And in addition, in the web tier, you also have this sort of local cache that's running along with that Facebook or MySpace application to kind of fetch this from the distributed cache servers. So when you actually create a friend list or username, it does go into the data tier, but it also goes into the distributed caching for faster access. The next kind of data is what we call as activity-oriented data. And as the name suggests, it's data that's generated as part of a user activity or a business activity. And simple examples, your shopping cart. When you go to any shopping site, your shopping cart is the data in the shopping cart is generated as part of your activity. And the characteristic of this data is that it's read and written at the same time, but it's usually partitioned. It's like your shopping cart, you're the only person who's going to go access it. And the scale requirements are that you should be able to handle a large number of these shopping carts. But the good part is it is kind of quite partitioned neatly. And if you take a sample scenario like an enterprise log application, like we went and looked at some of the insurance companies. So they have one of the classic examples where they have these insurance providers. So they get these various vendor sources and pricing information, which are the catalog, and that forms your reference data. That's put into the distributed cache. In addition, the actual process of buying insurance is your activity. And that also is put into this distributed cache. Another property of this activity data is that once the activity is done, typically it's now retired to some backend system or to some workflow or other systems for processing, further processing. The final kind of data is called resource-oriented data. And this is kind of the best or worst of both worlds, as you can imagine, where the same piece of data is being both read and written a lot. Classic examples, your bid quote auction, for instance. Or if you take the flight inventory scenario that we are explaining here, your seats, when you go to the reservation and actually click on the seats that you want to book, that's a resource data. And as I said, the scale requirements are that you should be able to support a large number of reads and writes at the same time on this concurrent piece of data. We took a sample example, Expedia, Travelocity, any of these websites. You get the airline information, like the flight segments, flight price, and that's your reference data. And the actual process of booking the seats, that's your activity data. And the seat inventory is the resource data. And companies or businesses try to, for scale purposes, they do try to relax some of the consistency requirements in resource data. And the easiest way to do it is to, for example, in airlines, they always overbook. Or if you look to Travelocity or Expedia, you sometimes see the seats, and when you actually try to book, it's really not there. So you can do some funky things to kind of scale up this data. And we'll talk about that as we go along. So coming back from that to your sample application, let's take a very simple application like what you would write with having some product catalog that you display, you have some shopping cart, and you want to check it out. Even in this, you see that there's all these three kinds of data that play a big part. For example, the catalog that I show you is reference data. The shopping cart that you might write in your application is your active data. And you have some inventory in the back end to say, hey, is this data available or not? That's your resource data. So we'll run through this shopping application, as you see in some of the demo scenarios later. So jumping in, what is velocity? So velocity is a distributed cache. And the words there actually have a lot of meaning. It's an explicit distributed in-memory application cache. So you can put any CLR object or any serializable object or byte array into this distributed cache. And what it is you take a bunch of machines, you put this service, install the service on all of the machine, and we virtualize it and give you the notion of a big cache. And how big the cache gets is how many machines you have and how much memory that you have on those boxes. So where does it fit in your typical application? So typically, you're going to have your ASP.NET or your CLR apps, which are accessing your data tier. Maybe it's accessing the database. Maybe it's accessing the cloud services. Kind of Velocity can nicely slide in there as a cache tier in your three-tier model. It's kind of be a fourth tier there. And again, the arrows mean a lot of things. Your app is there. We have the Velocity client DLLs that we supply that you put in your app that can talk to the Velocity service. Addition, your app can directly talk to the backend and use Velocity as sort of a cache aside where you put things into the cache, get it out of the cache, or you can write providers to Velocity so that if the things are not in the cache, Velocity can go fetch it for you. So Velocity can slide in between your data tier and your app tier or as a cache aside, as a cache tier separate from the two. So why would you want to use Velocity? So what's great about it? You're going to see a bunch of things. First, you're going to improve the application performance because you're going to cache your application objects closer to your application. It's not just the data rows or anything. It's your app objects, whatever they are. You can scale very easily. You can add as many number of nodes as you want if you want to improve the memory, improve the performance. If machines die, you don't have to worry about it because we have HA available in Velocity. And best of all, you can do this all at low cost because the V1 features that are going to come out is going to be free. And it's out-of-band release on MSDN. And you can use any cheap commodity hardware. We don't have any, as long as it has memory and it has network card, you're fine. You're good to go. So when can I get it? We release the CTP1 community preview in TechEd in June of this year. CTP2 is out now. You can actually download it if you go to the website, msdnmicrosoft.com/data. And we're planning to have a CTP3 in mixed time frame in March, and the release sometime middle of next year. So now that we've gone through sort of all the data concepts, what is velocity, when can you get it, let's kind of dive deep into some of the features that we have and the concepts and the logical hierarchy and so on. As I said, velocity, you take a bunch of machines, you put all the services on those boxes, and now you want to access it. So in the logical hierarchy of velocity, we give you what is called a named cache. A named cache is nothing but a bunch of policies that you apply to a cache, and you stripe them across this cache cluster. For example, I've created these two name caches called product catalog and electronics inventory. Product catalog, I might say it's kind of reference data, so I might not have eviction on. You can have a bunch of policies at the name cache level. The good part is your clients can connect to any of the machines and access the whole cache as if it was just a local cache available to the application. Within the name cache, we have the notion of regions. Regions are sort of like tables. It's just basically containers. The only thing we guarantee is that if you put items within a region, we will co-locate it on a machine. You don't have to use regions. You can just put the keys and values, which means the keys will get distributed across the cluster. And within the region, finally, you have a cache item, which itself is a key and values and tags, payloads, et cetera. So this is sort of the logical hierarchy of velocity. Now, given that, let me just give you a quick example of how you use velocity. All you do in your client, you just say cache factory is new cache factory. And then you basically go to the factory, and you get the name cache that you want. For example, in this case, I could say catalog cache. And then all you do is catalog.put. You give a key and some value. The value can be an object. It can be anything that is serializable. And then from either the same thread or a different client, you can say a get by the key. You will get the object back. So it's as simple as that. If you optionally want to use regions because you want to put a bunch of objects together so that you can kind of maybe retrieve them together, you can do queries or other things on that container, you could do that too. You just have to explicitly create the region and kind of put the key and the values within that region. So I'm going to show you a quick demo because the one question that people often ask is, OK, now this looks good, but do I need a DBA for this? Absolutely not. Let me show you how you can actually go through the whole install. I'm actually going to go through the install on 2 machines and show you how simple it is. So let me start the installer here. But I accept all the terms. And all I'm saying is start the installer. So this is a 64-bit installer. I'm just installing on this box. And the first thing, or the only page that you're going to get in the installer is this thing, a place where to store the cluster configuration, service ports, and the amount of data that you want the cache to be, the amount of the size of the cache, rather. Now, there are a bunch of options in this cluster configuration. I'll get into more details on each one of them. Let me just choose the XML-based file, and then I'll give the network share. So I've created actually a network share on my local drive called f:/inst_demo_share that I'm going to share with the other boxes. So let me enter the machine name. That's a local machine, 808.3714. Let me test the connection. It says, do you want to create a new cluster? Yeah, sure. I give a new cluster name, and I do save and close. It says, please select cluster size. The cluster size here determines some of the defaults that we use for things like the number of partition, number of regions that you want to create automatically, what's the queue size, et cetera. So if you have small cluster 1 to 3, choose small. So we'll default a lot of things for you. You can go edit them later if you want, but kind of choose the right appropriate size for your cluster. So in this case, I just said small, and I said yes, and it's going to go ahead and basically go create the cluster. the meantime, let me quickly explain what this cluster configuration store was. Lastly, there are really two configurations that you have with Velocity. It's done installing on this box. And it also installed this tool for me. It's a partial tool. I'll start that. And let me go to the other machine, actually install that on that as well, and show it to you. So there are really two pieces of configuration information that we store. One is the actual policy information. If you have all these name caches, right? So what is a policy, all that stuff. That's one configuration. The other configuration that we have is the distribution of the keys across all these clusters. The reason we want to store that in this demo, in this kind of network share, is so that one machine, the machine which is kind of doing that distribution goes down, some other machine can pick it up and quickly restart. So I've actually BL1 CDB 80824. Yes, it's already picked up this cluster name, so I'm just going to say save and close. So this is going to go ahead and install it on this box as well. And the other policy, as I said, the network share also stores the general policy of the name cache policies. You could opt to not use a network share, but then you would have to then go to each of the local boxes, keep updating the policy if you want to add a new name cache. So it's kind of advantageous to use this network share feature. We also have an option for you to use SQL Server if you already have SQL Server to kind of store all this config information on the SQL Server instead of a network share. So it finished installing on these two boxes. Let me go to the first one. With CDP2, we also have PowerShell integration, so you can actually do all the administration using standard PowerShell, and this is kind of the shortcut that was put on the desktop when you installed Velocity. So there are some standard commands here. Get cache host, for example. It basically gets the entire cluster, all the hosts, and their status. I can say start cache cluster, which will start actually all the cache machines. And there are a bunch of other useful commands as well, like cache statistics, which can actually go across the cluster, get all the statistics, and give it to you. Get cache region, which shows how the data is actually distributed across these clusters. So while it's actually starting up, let me also then fire up my client. So in VS, all I've done is just created a main, and I've used this using system data caching. So this is a new namespace that we have, and all the Velocity APIs are under this namespace, system data caching. And also what I have done is on the right side here, I've just added reference to a few of our DLLs, like cache base, cache main, cache base, and client library. So there are like 4 DLLs that you have to reference. And in addition to that, you just have to do an app config. Very straightforward and simple. There are a few items in the app config. Let me explain what they are. You have this host property here. What that says is all we need on the client side is an access to one host of the entire cluster. That is all. And given that one host, in this case, I've said 3714 and the cache port, we automatically contact that and get a map of the entire cluster. So we have access to all the machines. So this client can actually connect to the entire and talk to the entire cluster. And we also have the option of a local cache, so that you can actually cache objects locally if you want to. And we also have routing simple or we have the notions of a client which can be either routing or simple, where routing means the client can talk to all the machines. Or you can say, no, the clients should only talk to some gateway machines, and they should get routed through that. So that option as well. So let me go through the program. Let me just give you a simple set of APIs. Here, I think I've copied it here. So first, as I said before, I have to get the cache factory, and then I get the cache from the cache factory. I put them here. All I'm doing is getting the cache factory, getting a default cache. I'm just putting A1, V1 here, and then returning the value back and kind of reading it from there. So let me just run this program quickly. It's kind of a dumb program, but you kind of see how simple it is to install the whole cache, write a simple application. And you can make this, it's just starting up. You can make your app pretty fast, scale, and make it available, as we'll go and explain more. Result is oops, it just disappeared. So the result was V1 if you had caught it. Let me go to the admin tool and show you the fact that for the default cache, you would actually see that there's one item in the cache, and it's about 282 bytes or something. There was a total item count, and there was like 2 requests that are happening to the item. The other things, as I said, we also have the notion of region. So I'm just going to show you some examples with region. I've already kind of typed it here. What I have done first is I've added this region called toy region. Then I'm going to add a bunch of items to that toy. There's another interesting feature that we have, which is called tagging, sort of similar to Flickr or other tags, right? So when you insert keys on objects, it's not just keys on objects. You can also insert tags along with the object. So in this example, I'm inserting a bunch of toys, like toy 101, it's a musical toy, it's a playmat, it's a piano, it's a toy engine, right? But along with that, I'm also adding some tags, like, hey, this toy is for infants. This toy has a free shipping on it, for example. So you can just imagine. You can pretty much add any tags that you want. And the good part is, obviously, you can now search back on the tags. So it's not just the key lookup. You can also search on the tags. So if you go down further, what I'm going to do here is do a tag search. And that tag search, all that is doing is basically calling this API called getAllMatchingTags. And that's going to basically search on all the matching tags and return me all the objects. So let me just run this guy and see what happens. It starts up first. Yes. As you can see, it first created the toy region, and it's reading back all the toys. So these are all the toys. Now I'm just going to search for all the toys that have free shipping. So that get tag search was looking basically for free shipping. All the musical toys had free shipping, so they came back. So you can imagine searching across the whole cache, looking for just some purchase order that has toys in them or various other things. So right now in V1, the tag search is limited to, and this is an AND search you can do as well. You can do ANDs or ORs, and we're looking to add more features going forward, like range searches and the classic link queries as well on them. So that's about the install and kind of the quick demo on how you can use. Hope you're convinced that it's pretty simple. It's not like rocket science. You don't need a DBA for this. You just install on a bunch of machines, use PowerShell, you're good to go. So what are all the features? Yes, it's very simple, but we do have a lot of features as well. And as I said before, the simple access patterns like get, put, remove. We also have tag searching. We have both the partition and local cache that we will talk about very quickly. We also have high availability. What that means is that even if machines go down, if parts of your caches go down, we still preserve the data. You don't lose your data. And that's new in CDP2. We also have multiple concurrency control operations. You can do lock-based operations. You can take a lock on an object, or you can do kind of optimistic version-based locking as well. We also have ASP.NET integration. You can have actually session store. We have a session store provider, so you can actually talk through that and have all your session data put in the cache. We have management and monitoring tools. PowerShell is one, for example. We're also working on a bunch of other things like security, cache notifications, which I'll have a demo of in the next session, and server-side callbacks, so that if items are not found in the cache, we can actually default and kind of fetch it for you. So we went through the tags. We saw the demo. And as you can see, the other thing that I forgot to mention there was you can use enumeration. So if you have regions, you can actually enumerate on the whole regions. And if you do tag search, you also get back an enumerator. So you can imagine you can use that enumerator in your link, for example, link queries. And also, this is bulk enumeration, so it actually scales very well. It's not like we go fetch one item at a time. We actually fetch them in bulk. So it scales very well as well. So what are the various cache types? I kind of briefly mentioned the partition cache and the local cache. We have the partition cache. What it means is that the data is partitioned across the cache cluster. So if I give you 10 machines, and I give you about 100 keys, we're going to distribute the keys across the machine, like 10 per machine, right? So that's a partition cache. So, and that's the option that you'll get in V1 on the server side. Now, in addition, On the client side, you can also say that you want the local cache on. You saw that in the app config, there was that highlighted thing which said local cache on or off. And the advantage of that local cache option is that once you turn it on, as you fetch data, as you perform GET request, the objects actually come into your local cache. And if you have locality of reference, you don't have to go across the wire, across to the service to fetch that objects back. And we actually synchronize that local cache using either expiry or some notifications as well. So we'll talk about notifications more in the subsequent talk. So how does the partition cache work? Let's take all these applications here. You have 3 applications with velocity clients on all of them, and you have the cache servers here. And assume these keys are being kind of given by A, B, C, D, E, F, and GHI, or the various keys and the values that are being fed by those clients. And what we have is an automatic partitioning across the machines. You don't have to manually do anything. We take care of it. We also have load balancing, so if stuff happens, you add a new machine, again, we will kind of repartition the keys and go across the cluster. And the partitioning is kind of range-based partitioning, so again, it's not like fixed hash or anything like that. And so what does partitioning help you? So why is partition cache great? Because you can scale the data sizes. So as you add more machines, as you actually need more data, if you suppose you have a gig data, now you want 2 gigs, all you do is just add a few more machines for the cache, and there you have it. You can cache now all your 2 gigs of data. You can scale on the cache throughput as well. Cache throughput is the number of total operations that you can do on the cache. And if you have more machines, obviously your requests also get distributed across the machines, so you have more throughput. And obviously, you have higher performance as well, because if you have more machines, the latency per request is actually lower as well. So I'm going to show you another quick demo on how this actually works. This is a scale demo. And what we have in this demo is actually a load test controller. We're using the Visual Studio load test controller and about 10 different cache clients. These cache clients are going to go against these cache servers. So I'm going to first start with 1 cache server, increase the load to about 60 clients, hit that 1 cache server. You'll see that the cache server struggles to meet that load. And then we'll slowly add the other cache servers and see how your throughput and the latency actually graphs behave. So let me switch to my laptop here. So I've just started the load run on this, and while Visual Studio tries to install it, actually this is part of the VSTS. What it does is you give it a bunch of client code, and it can actually automatically go copy to all the clients and start the tests and give the results back. So while it's doing that, let me quickly show you what the code is that we're executing. This is going against the CDP2 bits. So we have here a simple example of the shopping cart that we talked about before. I have a cache.put operation. I'm just generating a new shopping cart ID, and I have about a 20K sized shopping cart payload that I'm giving it to it. And it's just starting the test here. And then I also have a get call immediately, and then finally a remove call. So it's really 3 different calls that I'm doing against the cache. And here on these boxes, these are the 3 server boxes. I have 18, 19, and 20. And if you go to 20, you see that basically amongst this cache service, there's like 1 cache service that's up, service 20, and then the other 2 are down. So there's only 1 machine that's running right now. And the load test has just started up, so I'll zoom on this window. So this window actually tracks 3 different things. It tracks basically the load on the system, it tracks the throughput, and it tracks the response time, the latency. And remember that it's tracking it at the level of each iteration, and each iteration, 1 iteration is really the put, get, and remove. It's really 3 different cache operations. So let me zoom here. As you can see, the red is the load, and it's sort of doing the step pattern. It goes up to 60 different clients running on 10 different physical hardware. And the green is the actual throughput. And as you can see, the throughput initially kind of goes up and sort of flattens out after some time, and the response time keeps going up. And right now we're doing about, there are 60 threads, and we're doing about 2,500 or so iterations. That's about 7,000 operations per second, 7,500 operations per second on the cache, with a response time of about 22 milliseconds for those 3 operations, like 7 milliseconds, kind of high, right? And let's see why that is the case. If you go to this box, the network card on that machine is saturated. As you can see, it's just 90%, almost 100%. Not the network itself, it's just the network card on that machine. So what I'm going to do is I'm going to go here and just going to start another machine, BL1, CDB 808, 3718. So what I've done here is to just start one more service. So as you can imagine in your business, yes, you're going to have a huge load. So what do? You just add another new box, install velocity on it, and just say start, right? So while this is starting, let me also explain what happens here. The first box was up. All the data was in that box. Now you bring up the second machine. It's going to join into that cluster, and immediately the load balancer kicks in and says, this machine is now empty. Let me move some of the data over here. In CDP1, we didn't have replication, so if you added a new machine, well, we moved the metadata, but not the data, right? So your app had to repopulate that cache. Whereas now in CDP2, we also have replication, so you don't actually lose any data. When you add the new machine, part of the data actually migrates over to the other machine. So there's a command called get cache region, which kind of shows the distribution of the regions. So you see that this primary kind of thing for 20, and then you also see 18 here, right? So you saw 20 and 18. So there's so many of these regions. Now they're getting distributed across these two machines. And let's go and see what happened to our response time and throughput graph. As you can see here, the throughput was kind of here. It literally almost kind of like doubled. Not exactly doubled because the load on the system is not that high, so it doesn't double exactly. But you can see it jumped up to 4,000. It's around 2,500 or so. It jumped to 4,000. That's about 12,000 operations per second. And as you can imagine, latency actually went down as well. You see it's now 12 milliseconds for those 3 operations. It's about 4 milliseconds per operation, right? And let's see how the machines are behaving. This is about 60% load here. And machine 20, let's see, it's still around 80%. So let's add the second box and see a third box as well and see what happens. I'm just going to go and add 19 here. So it takes a while, and when a third box gets added, as I said, 1/3 of the partition will get moved. So it kind of nicely gets distributed as well. And so it's not just when I delete a new machine, the load balancing actually happens even when the machines are actually up and running. If we detect that, hey, maybe one region is, maybe you inserted too many big objects, right? Maybe this is growing too big. We try to do load balancing as well. And if I do the get cache region, you would see that the data is now going to go to the other box as well. 18, you'll soon see 9. It's not started the load balancing yet. In a few seconds, you should start seeing 19 as well. See, about a few seconds, it started to show 19 as well. And you would see that there's a further jump on the throughput. It's not going to double here because the clients are not generating enough load. 60 clients are not enough to saturate these servers. The servers can handle a heck of a lot more. So, but you do see that jump up, and now the response time has gone down to like 10, right? So it's about 3 milliseconds per op. This is a 20K payload. And we can do much, much better if it's like smaller payload numbers as well. I'll get to the performance analysis later. So that's the scale demo. So let me jump back to the slides. So you can see how simple it is to just add new machines. If you want to get more throughput, you want to get more scale, and improve your latency numbers. This was in case the demo didn't work. So partition with HA option. So what have we added to the partition cache? So yes, I said the keys are partitioned across the cache. And what happens, so the keys go like this. And what happens if machines go down, right? So that's why we've introduced availability. So at the name cache level, you can actually set a property called number of backups. So you can set it to 1, which means every key or every key value is actually copied 1 more. Or you can set it to maybe 2. We can actually handle multiple backups as well. So in this case, what happens is the backups are created, and they also get distributed across the cache. So what happens when this machine dies? We automatically figure out that, hey, D, H, and A on that boxes, this is kind of what we call the primary box for those keys. Hey, it died, so let me create backups. The backup copies on these boxes now kind of become the primary so that you don't lose the data. And for the other backups on this machine that were lost, this F, E, and C, we create now new backups and kind of distribute them across these boxes as well. So that is in short what we do with availability. This is kind of a higher level overview, and as I said, in the next talk, we'll go into the actual details of the gory details of how we actually do all this message routing and figuring out what should get promoted and so on. Before I jump to, obviously I need to show a demo as well, right? So before I jump to the availability demo, let me tell you what we do with ASP.NET so you kind of get familiar with what the demo does. With ASP.NET, we have done session cache integration. This is ASP.NET exposes a standard API called Session State Provider. So if you put any objects into your ASP.NET session, if you implement a provider, those objects will be given to the provider for safekeeping. So what we have done is also provided a velocity session state provider. So all you have to do is to go into your ASP.NET code in the config and web.config and just add our provider name. That is all, right? And then whatever name cache you have that you want the sessions to go in, you set it there. You set the name cache, and that's it. And what happens is then your ASP.NET application that was using sessions, all those session objects will silently now go into velocity. And you can see how it's going to, in that demo that I'm going to do right away, you'll see how that can improve your ASP.NET session, both from scale, performance, and availability. So as I said, actually, I'll show it in the demo. It's probably much easier that way. Let me switch to B here. So let me close this guy. So I actually have two different machines, Anil Nori 4 and Tweety. And they have a standard ASP.NET application running that I had showed before. This is a Northwind application, and all this is doing is showing sort of the catalog, and you can choose from the catalog, add to your shopping cart, and you can see the shopping cart. It's a very simple app. And let me go into the Anil Nori 4 and actually show you how the website, what we did with the website. So this is the default website. Let me explore here. And here in the web.config, as I said before, we have just that one line that says velocity session store provider. And that is the only change I had to do. In addition, I have actually velocity running. So here, this is the standard stuff. And I pretty much have here saying velocity is the session store provider for this case, and how to contact velocity. That's the client configuration that we had to put in the app.config. That is all you needed. And I also have velocity now running on 3 of the machines. I have Anil Nori 4, Tweety, and Eagle, those 3 machines. So as you see, the machines are all up and running. And let me quickly go to the demo and show what is here. So I first do a show cache. There's basically nothing in the cache. So for the demo purposes, I'm just going to call populate cache. What the populate cache does is it goes, reads some data from the file, and it's just populating this reference data in effect, right, into the cache. So now I do show from cache. As you can imagine, it's fairly fast. It's about 15 milliseconds, actually go down to 0 as well. Now the good part is this. Now I come to Tweety. Now Tweety, I didn't do any population, right? If you just had local caches, Tweety would have to also populate. But now I do show cache. You can actually see that Tweety will also get it from the cache. I guess it's initializing its client. Yeah, there you go. So the first time was a little high, but now as you can see, subsequently it's 0 millisecond. So this is the advantage. So if you have a bunch of ASP front-end tiers, your reference data can sit in the distributed cache. You don't have to populate each one of them, right? It's already available. If one of them populates, everybody gets it. Let me show you the other part as well, and which is I'll choose a bunch of these items. I'm going to add them to my cart. And once I add them to the cart, what is happening here is that this session information, this is your activity data, is going into the ASP.session store. And because we said the ASP.NET session should be stored in velocity, that goes back into velocity. And I'll show the cache for you and cart for you. You see a bunch of items in the cart. And let me go actually to this machine and show you the cache region. You would see that all this data kind of got bucketized into these regions, and they get distributed across these machines. So you see that Anil Nori 4 has a bunch of machines called primary and secondary. So the data is there is one backup kept for each data. So you see some of the machines are getting some part of the data, and other machines are getting the backup copies of the data. So now let me go to Anil Nori 4 and look at the cart. Obviously, there is no cart on Anil Nori 4 because the session information is different. So let me do some trick here. So I'm just going to spoof the session. So I'm going to copy the session ID from here. Go to this box. So what I've done here is I took the session from the other URL, if you will. I just spoofed the session. And you can see that from Anil Nori 4, I can access the cart. What does this show you? That you don't need sticky load balancing, right? So once you have the distributed cache, and the distributed cache is storing your session data, you can go to any of the front-end boxes and access your session. You don't need sticky routing, which is a scalability bottleneck, right? And the good part is, because we provide high availability, your machines can die, and we don't lose your data. So I'll do 2 levels of death. Let me kill one of my ASP.NET app first. I'm going to kill ASP.NET app. Because the ASP.NET app itself doesn't have any state, it doesn't matter if these things, the front-end servers die, right? The front-end ASP.NET apps die. So Tweety is actually dead. And if you go here, I can still show the cache. The cache is still here. I can still access that card that I had, right? And just to prove that Tweety is indeed dead, if you go to Tweety, it is indeed dead. That machine is dead. It doesn't matter. OK, then you can say, oh, well, that's just a front end. What happens to the cache itself? So let me go kill the cache. So I'm going to kill Tweety now. -P22233. I'm going to actually stop Tweety. So actually, I killed one of the machines here. And let me do the get cache region. You would see that Tweety would be dead. But then slowly, the data is now getting partitioned across Eagle and Anil 4, those two machines. And you would, if I just refresh quickly, you would see that the primary and secondary kind of get migrated, as I explained before. And you saw that more secondaries got created, more backups got created. And let me go back to this guy and show that the cache is still there. The cart is still there. And I can kill pretty much every one of the machines. I can go and kill Eagle as well, and it'll still work, because then it'll all go to just one machine. I've stopped this as well, and you can see that pretty much everything now just migrates to one machine. So that's the power, right? So by putting this distributed cache in your ASP.NET app, you can both scale your app, because you can now cache more data closer to your app. You can make it more performant, because it is closer to your app. Your latency time is pretty fast. And also, you can make it highly available, because even if your ASP.NET apps die, your clusters die, you don't care. Your data is actually safe, both your reference data and your activity data and your resource data. So now you saw that Anil 4 pretty much has taken over all of the remaining data there. We talked about this. I sort of showed in the demo. Administration monitoring, we have, you can do the install on each of the boxes. We are also working on doing some silence or remote install as well, so you don't have to actually physically go to each of the boxes and do the installing. Logging, we have a provider-based model. By default, we supply ETW file syncs. You can write your own sync provider if you like, and you can plug it into Velocity. Administration, we have partial commandlets, and you saw all of that in the demos. We also are working on Perfmon integration. And further going forward after V1, we will also work on more GUI tools. I think partial V2 already comes, for example, with standard GUI, which you may be able to use as well. So configuration store, we kind of briefly talked about this as well. The configuration store can be used to store two types of configuration, right? The name cache policy level information, as well as the kind of the global partitioning of the data. So in this case, for example, one of the machines runs this global partition manager, which tells everybody else saying how the keys are distributed across the landscape. So that information, we put it in the configuration store. This was the one earlier on in the demo I was showing XML provider or SQL provider, all those choices, right? So you can store them either in network shares or in SQL Server. And we're also working to see if we can actually not even require that. We can actually just get it from the rest of the boxes as well. So going forward, we'll also have other options that you don't even need to give us network share or SQL Server. We'll just figure it out from the rest of the machines that are in the cache. Putting it all together. So now that we've kind of gone through all these APIs, we've gone through the features, let's put it all together. So if you come back to your reference data, so you have the social networking, and where can Velocity fit? What features of Velocity can help you there? You can obviously put Velocity as a cache service, right? You can put all your friend lists and usernames in these massive Velocity cache service. And because it's a partition cache, it can help you scale very well, right? And you can also use the local cache option of Velocity with the local cache client turned on. So essentially, your web tier can also perform. Now, your username ID mapping is both there in the local cache and the cache service. And we have varieties of ways where you can actually sync the local cache with the cache service as well. If you go to the activity-oriented data, and what you have is you can have Velocity in this tier here with the session store provider for ASP. So you can integrate with ASP session store that gives you both session load balancing. It also, using the partition cache plus HA, you get scale and availability together as well. Finally, with the resource-oriented data, you can use the partition cache plus HA option. You also can use the various other concurrency control options that we have, which are things like the pessimistic locking and the optimistic locking, so that you can actually scale your reads and your writes better as well. So looking just ahead, so what are we planning to do? Some of the perf numbers that we've seen so far, this is by no means complete. We're still working a lot. CDP2, we can do something about 22,000 operations per box. If you just take one quad-core box, we can do about 22K ops for about 4K sized objects, and roughly about 0.3 to 0.5 milliseconds per object. I mean, this is pretty fast. And obviously, the more boxes you add, the more aggregate cache throughput that you get. So if I add 2 boxes, you can get 44K, for example, right? And if you add the serialization, deserialization overheads, we roughly get into 2 to 3 millisecond range. And that's where you have the choice. For example, you don't have to use, we use the net data contract serializer, for instance. You don't have to use that. I mean, you can write your own serializer, just give us byte arrays. We can keep them for you and give it back, right? And the session store itself, we did about various different tests. We did 50K sessions that we stored. We saw that we were roughly around temporary table performance, SQL Server temporary table performance. We were kind of close to that, but we were obviously quite fast than, say, the SQL Server persistent store. And obviously, the advantages Velocity gives you is it's in memory, it's cheap. You can scale it out better as well by just adding more machines. So if you want to increase to 100K sessions, just add another box. You can kind of increase your scale and performance. Some of the things that we're working on going forward is bulk access APIs. So we're also trying to add, instead of having every get and every put going to the backend boxes, we're also going to make bulk access so that you can actually get them in a chunk as a get or put them in a chunk. Obviously, it's going to give us much higher throughput numbers. Security is always kind of a big thing. And one of the requests, one of the things that we heard feedback from, say, TechEd was that keep the security very simple and straightforward. And so what we're going to do is the default, obviously, is a no security option. Because if you're really important, if performance is very crucial and you know your cache is kind of behind firewalls, nobody's going to access it, don't use any security. You'll get the maximum performance, right? The other option is what we're working on is a token-based security model, where you can actually, when you have the name cache, you can actually supply a token to the name cache. So what will happen is when you do this get cache connection, you actually have to then give that same token. So this will just help make sure your apps don't accidentally go talk to the wrong name cache. And the second option, the third option that we also have is an app ID-based model. So in the app ID-based model, what we're going to have is you just have domain account-based authentication. And so your clients, whichever the standard ASP.NET domain authentication, so your service will be authenticated. And it has to be in the same domain for you to be able to use the name cache. There's also transport level security. So internally, we use WCF for all our communications. So you can actually use, pretty much go and tweak and add all the standard WCF transport level security, like encryption, compression, whatever you want there as well. So it kind of gives you, it's an open-ended thing. So you can pretty much add what you want at that level, at that kind of a lower level. So these are going to be the various security options that we're looking at. So this is going to be the schedule. We did the CDP1, as I talked about before. CDP2, we have availability. The new features are availability, PowerShell, and some of these configuration options, like talking to SQL Server and so on. CDP3, we have bulk access APIs, security, read-through, write behind, and cache event notifications. Let me just quickly explain what they are. Bulk access, as I said, is where we kind of send the gets and the puts in bulk. The security, we also talked about right now. The read-through, write behind is if you go into the cache, you try to read something. If it's not in the cache, who takes action? Whether the application has to now go fetch it from somewhere and put it into the cache, or can the cache call some callbacks so that the callbacks can go actually fetch it from whichever backend provider. And similarly, the write behind says if you put something into the cache, can we asynchronously now call some callbacks to write it to the provider? So this the cache can kind of seamlessly sit between your app tier and your data tier without you having to worry about knowing the cache as a separate entity. Cache event notifications is any change to the cache, you can actually track it with the use of notifications. So you can actually register, say, at the cache level, saying any change that happens, the whole cache cluster wide, let me know, or at a key level or at a region level. So those are some of the various things that we are planning for CDP3. And finally, RTM, our plan is to go by middle of next year. So kind of the recap of the slides. What Velocity can do is to help you scale your app, make it faster, and make it available using all these features. And as I said before, all the V1 features are free, so you can actually use it. You just install it on your boxes that are maybe just sitting idle, you can just install Velocity in all of them, make a cache cluster, and actually improve your app performance. So if you're evaluating and recordings, please go to the Microsoft PDC and give your feedback on this, and we can have kind of an elongated Q&A. Any questions on Velocity? Yes?
So is there any way to lock an empty cache key? So if you've got two front-end servers and then one caching server, to where you go in, you see it's empty, but then you execute the 30-second query to populate,
right,
that'll block the other server,
right,
from executing it twice?
Yeah, good question. So yes, we're looking to see the get and we have a call called get and lock, and right now the get and lock call basically says, hey, if the key is not there, we don't give the lock. But yes, we're looking to see if we can add a lock if the object is still not present. But the other option as well going forward, we're going to have the read-through right behind. So that will also help you, because when we have a read-through provider, if the object is not there in the cache, it will call the read-through provider. So other operations will block, other reads will kind of block. So that's the other option that we can use.
So is Velocity going to have the same types of cache dependencies as, say, the web cache does today? Things like file dependencies,
right,
database?
SQL dependency and so on. Yeah, good question. V1, we're not planning to do that right now. V2, we're looking to see how to do better SQL integration, and as part of that, we're looking to see how to do SQL dependency and so on. Because some of these things are tricky. If you take file dependency, for example, you add some file dependency to your client. What does it make sense on the backend tier? It's very hard to track, right? So the only way today that you can do is you can have your own client doing the dependency and kind of invalidating the object in Velocity. So that's the only option. But yeah, in V1, we're not looking to provide it, but later, yes. I guess see.
Is the Velocity going to be available if and when with Azure Web Services?
Good question. So we are working with the Azure team to kind of put Velocity in the backend. We don't have a time frame right now when it's going to be available, but we are working with them very closely to get it up and running. Yes.
This is kind of both a question or a suggestion. Are you guys working with the Windows HPC team? Because
yes.
I can definitely see this as a huge potential.
Yes, in fact, okay, the question was, are we working with the Windows HPC team? The answer is absolute yes. In fact, we've run a lot of benchmarks internally, and we do see a huge amount of improvement in a variety of areas, like both as sort of an intermediate store for some of the result calculation, or for like caching reference data in HPC. So we've seen a lot of results there. Yes, we're working with them closely.
But the right behind feature is going to be critical for that. So you said it's coming in CTP3. Is that a maybe, or is it definitely going to be in CTP3?
For sure we're trying to do that, but obviously, nothing is cast in stone until we actually get it out. So.
Okay, and regarding your UI
but we're really
tools,
trying to make like right behind app.
Regarding UI tools, they already have awesome UI tools over there to
yes.
configure clusters and everything. So if you just integrated with them, that'd be awesome.
Exactly. In fact, in Anil's talk, the subsequent talk, we're going to go into more detail of that as well.
Okay,
so
thank you.
Absolutely, we're doing that.
What type of cache inspiration you'll provide? What models?
So we have an LRU-based expiry model. So you can actually turn expiry on or off, and you can actually specify default expiry on the named cache level. So if you add objects, they'll have default expiry, and you can also specify expiry at per instant level. Now there's two things, right? There's expiry and eviction. Right? Expiry is saying, hey, this object is no longer valid. So anytime you try to get the object, if the object is no longer valid, we will throw it out. Or we actually have frequent threads that run and like clean up these things. Eviction, we have an LRU-based eviction. So if your cache exceeds certain thresholds, we actually trigger eviction to throw things out.
Yes, but this will not be available on the catalog level or something. For example, I want to expire full catalog. Catalog is a representation of the table from database.
Right. Okay.
And I want to expire, for example, I have added something in the table, I modify something there, and at this moment I want to expire the
whole thing.
The whole catalog. That is my, let's say, mirror of the table.
Right. So that's a good question as well. So a few things we're thinking about. These are, again, wish list kind of items. We're thinking at region level expiry. So maybe in the case of regions, you can map them to tables, and maybe you can expire the whole region at one shot. Today you can do that, right? Today you can kind of drop the whole region. So if you put all the items in your table into that region, you can drop the whole region. But we're looking to see if we can do expiry at the region level as well.
Okay, thank you.
Yes. When you pass an object into Velocity, when will the message return? Once the object is serialized, or once the replication is also done, or will it return immediately?
I didn't understand the question.
Okay,
sorry.
you pass a non-serialized object
Correct.
to velocity.
Correct.
Velocity then serializes it and distributes it to
Correct.
the other nodes.
Correct.
When will the method return? Is it an
Oh.
instantaneous return or
No.
only after?
Good question. So is it a sync call or an async call in effect, right? Right now, all our APIs are synchronous, so it will not return until it has gone to the node, actually put the data, and come back. We're looking to provide async options as well, so that you can scale your clients better. But right now, it's all synchronous APIs. So it will not return back until it has gone to the server and come back.
Thank you.
Sure.
Okay, my question is on the collision. If two applications are trying to use the same cluster for caching, and if they happen to have the same key name, how do you avoid one application?
Not overriding the other? So that's where you use the name cache concept, right? So what you do is at kind of deployment time, you create different name caches for each application. Like suppose you had a purchase order application and a shipping application. You can create a name cache called purchase order, right, which the purchase order application uses. You can create a shipping name cache, which the shipping application uses. So these things won't run into each other. The keys are all unique within a name cache, right? You can have the same key ID across name caches, they won't collide. So everything is sort of partitioned at the name cache level.
So whatever the name that we give to the cache, that's what you're going to keep. You don't add anything special to
We don't
that?
add anything special. So you can create a name cache called purchase order application or something, and then put everything into that. Remember that get cache factory, you said that cache factory.get cache, we were giving a name, that is a name cache name. So you can use different names for different apps, so then your keys won't collide.
Okay. This is going to be critical, especially when you run on a pooled application, right?
Yes,
When you have an application pool, running a web application, but from two different processes, right? Like you don't necessarily how do we manage that?
See, your question actually is two different parts, right? One is you said there are different applications and you don't want them to overwrite the keys, right? The other part is, are the applications sharing the same data or not? If the applications have to share the same data, then you want them to share the same name cache. And at that stage, you can either just do regular puts, you can keep overwriting each other, or you can use different concurrency models. Like there's a locking-based concurrency as well as like an optimistic concurrency model that we have. Again, we'll go into more details in the next talk, but you can use either of those two options if you want to prevent the other apps from overwriting each other.
Okay, thanks.
Yes, I saw in the demo that you had 8 gigabytes maximum address space.
Right. I had
Is
4
that
gigs,
correct?
I think. I had 4 gigs for the cache itself.
But you had in configuration basically that 8 gigabytes is a maximum. What if I have a machine with 64 gigs?
You can use 64 gigs. I mean, we don't see when we did the install, right? We figured out what the machine size was, and by default we gave like 4 gigs.
Okay.
So you can change that. I mean, you can make it anything we want, and we have 64-bit installers available. So yeah, you can use the entire how much ever memory you have on the machine.
Okay. Thank you.
I want to use to use the distributed cache to replace the ASP.NET session caching.
Session store.
So
yes.
how do you compare the numbers versus in memory?
The
state server?
out-of-proc, it's very comparable to out-of-proc. Out-proc is almost the same as far as out-proc is concerned. The ASP.NET's out-of-proc. Obviously, it doesn't compare to the in-proc numbers because obviously it's just within the process, right? But you got to take it a bit of salt, right? Because in-proc has its disadvantage, which is you have to have sticky routing. If the machine goes down, you lose your data. So this is very comparable to the out-proc, ASP.NET's out-proc session store.
In a scale-out situation?
In a scaled out
if I
situation. Yes, you can use it that way. See, you could turn on local cache if you want. If suppose your machines have sticky routing, right? Suppose you already have sticky routing, you can turn on local cache option in Velocity. So then you'll get the same performance as in proc. In fact, with the local cache, we can do something like 200,000 operations a second. I mean, it's some insane number. So you can turn that on if you have already sticky routing.
Thank you.
Sure.
Okay, that was my question.
Oh, okay. All right.
If I put a key in the store in the cache, somebody is modifying the object in the backend directly.
Right.
So how do I make the item in the cache stale?
The way to make the item today, you have to remove the item, right?
Okay.
So your application, in some sense, when I say today, as in CDP2, the cache doesn't have any providers. So you are putting some item into the cache. So when you're going to update the backend, it's your responsibility to put something in the backend and kind of invalidate the cache as well, like do the remove of the cache. Now, when we're going to provide all these read-through right behind providers, then you have a better chance where you can just write to the cache, and the cache will write to the backend providers, and the item will be available only after the write has succeeded, for example.
Okay, good. Thank you.
Sure.
You briefly went over a feature was like a local cache. Can you
Correct.
talk about that a little bit more?
Sure. So what the local cache is on the client side, you actually can have, when I say local cache turned on, when the objects come, when you do perform a get operation, the objects come across the wire, right? The serialized bits, they get deserialized. So if you have local cache on, that deserialized object will be kept locally in the client. So when you try to access the same key, the same object again, we'll then immediately return that object back to you. So we don't have to go across the wire, deserialize them.
If you're caching session and you run out of memory, let's say you max out your memory on your cache servers, what kind of happens in that situation?
So that depends, again, what policies you configure. So remember I said for the session state provider, you can say which name cache you want to use. Now, in that name cache, you can either turn eviction off or you can turn them on, right? If you have eviction off, then if you run out of memory, then we're just going to start throwing errors saying, hey, we can't do anything more. But if you turn eviction on, then what happens is two things. First of all, we by default take the expiry. We have an expiry attached to the sessions. It's the same as the default expiry on the session, right? So any expired session will get thrown out first. Now, even barring that, you have no expired session, it's just really running hot, then we will start doing LRE eviction at that stage. So that is your option. So you can turn eviction on, and we can kind of throw out those session objects.
So that's the same as any caching. You run out of memory. It doesn't start going to paging file or
it doesn't do
like
it doesn't do any of that stuff. So. Yes.
Hi. Towards the end of your presentation, you noted that one of the servers primarily serves as the global partition map.
Right. It's not any one of the servers. So even if that server goes down, someone else will come up and take that role.
Okay. And then my next question was, in your demo in the web.config, you listed just one node in the cache cluster. Can you list all three in case that node isn't up?
Absolutely. So very good question. So you can list as many nodes as you want. So we try to kind of or access each one of them one by one. If the first is not accessible, we go to the second and so on. Yes.
Okay. And in your demo, you took down a node out of the cluster during runtime with a command. What happens if that node actually goes out under less clean circumstances? Like
it's the same thing. See, the stop that I do is actually doing a SC to kill that service. So it's the same as it's a hard
just
kill.
like a hard crash?
Yeah.
Cool.
In fact, we're looking to see if we can do a soft shutdown where we can actually gracefully do all the migration and kind of shut down the machine instead of doing this hard kill. Because hard kill kind of does a lot of things in the background, right? Because the machine's suddenly dead, we have to figure out who's the secondary, who's the primary, like do all this in an urgent fashion. So we're looking at soft shutdowns as well, like graceful shutdowns. Any other questions? All right, thanks. Thanks for attending the call.